Hi, in this video we are going to be looking at how new seafloor is formed or how new crust is formed. Okay, so from last time we talked about rift valleys developing in continental plates and oceanic ridges that form under the, in the on the ocean floor, right? So we have one plate, right? And then that plate happens to have forces underneath it that cause its parts to move to separate directions. And again, when it does, it develops a crack because of the tension, right? This part is being moved that way, that part is being moved that way, it develops a crack. And therefore, eventually, this plate splits into two and you form a crack at the center. And again, this happens in continental plates, you form rift valleys. It happens in oceanic crust, you form mid-ocean ridges. But obviously a glaring question is, okay, sir, if these two plates, if this one plate splits into two and moves opposite directions and there's a crack, wouldn't we fall downwards to the center of the earth because there's a crack already, right? So that crack becomes bigger and bigger and bigger, so things will fall down and we eventually find ourselves in the core of the earth. Well, the answer is no, because if you remember, the plates are just part of the lithosphere, right? We are just part of the lithosphere. And you have to remember, under the lithosphere, there's still a sublayer there called yes, the asthenosphere. And this asthenosphere is, again, this is like fluid-like, and in fact, magma, right? Fluid-like molten materials of rock. So magma. So what cracks is just the lithosphere. So if the lithosphere cracks open like that, what happens is you will have access to the asthenosphere, and that means that asthenospheric materials will just simply come out of those cracks. Okay? So you won't open a hole directly towards the interior of the earth. What you will do is that crack will sort of become an opening such that asthenospheric materials can come out of those cracks. Okay, and so that's the idea there. That's the main idea there. And so what happens is when you have this plate, let's say at first it develops a crack like that, and then next they move further apart like this. What really happens is when that crack becomes bigger, the asthenospheric materials from inside the earth, namely in the asthenosphere, will just simply fill in that gap. Okay, will fill in that gap, and then these asthenospheric materials, which are fluid-like, will fill in that gap and eventually will cool down and they solidify. And when they solidify, they become new crusts. Okay, so they become new crust, and a lot of times this new crust happens under the water, so therefore you form new seafloor. Okay, so let us see that once again. So here, if again, when you have rifting, at first the continents and then you develop an ocean at the middle, magma still comes out, it pushes this oceanic crust to move that way and move this way, and what happens is, again, the asthenospheric material uh, fill in the gap, the crack, and will become new seafloor. So this is how it happens. So these two plates move apart, but as they move apart, magma comes out, fills in the gap, and gets solidified. And when they solidify, asthenospheric materials, when they solidify, cooled down by the ocean water, and solidify, they form new crustal material. In this case, they will form new seafloor. Okay? So when you open a crack in the crust of the earth, it doesn't really create a hole, so to speak, because when it does that, what it would eventually trigger is just the asthenospheric materials filling in that gap, and those asthenospheric materials would solidify and they would become new crustal material. And again, oftentimes these things happen on the seafloor itself, and therefore you form new seafloor. Okay, and just to connect this to um, continental crust, because we are talking about seafloor here, so we're talking about oceanic crust. You have to remember again that the oceanic crust is basaltic layer, and then again the continental crust is um, let's form a continent here, and let's have seawater like that. So what happens is this is continental land because it has both the basaltic layer, which is this blue one, and then you have this granitic layer. And the granitic layer um, simply um, simply is thicker, that it pops out of the water. That's why it's called granitic layer. Or maybe I did not draw that correctly, so let me change that. So maybe it's like this, right? Like that. And then you have the sea here. That's the ocean. So again, in continental land, you have basaltic layer, which is still technically underneath or under the ocean water's level. And then the granitic rock, it's formed above the seawater. And then this is basaltic rock here. So therefore, if you have a crack on the ocean floor like this, right? So again, just like what we said before, magma materials or atmospheric materials come out of that crack, fill in the gap, and then they solidify. Okay? When it solidifies, it becomes basaltic rock also. And so, what is basaltic rock? Well, basaltic rock is ocean floor. So you form new seafloor, right? And so therefore, how do you form granitic rock? Well, you form granitic rock when the magma materials will come out and will not be underwater. So for example, if there's a volcano here in the continents, let's say there's a volcano here, right? And obviously that volcano has chambers of magma. Then magma comes out here. Magma gets deposited here as lava. Those magma materials or astenospheric materials, when they cool down here, they will become granitic rock rather than basaltic rock. Okay? And the difference why it forms granitic rock versus basaltic rock is here, when the magma materials come out, they actually get is cooled down by the water, ocean water. So if they are cooled down by the ocean water, they have no time to expand. They cool down immediately. They do not react with oxygen in the air because there's limited oxygen underwater. So that process creates basaltic rock. Whereas if you have magma materials come out on land and it's not cooled down by water, it's just cooled down by air. So it has a lot of time to expand, it has a lot of time to develop its crystals, to react with oxygen in the air, to form silicates. Therefore, the thing becomes granitic rock, right? So, um, I'm discussing this because you might be saying, okay, we are creating new seafloor, which is new crust, but how do we create new crust which is not seafloor, meaning new crust which is continental in nature. So although our discussion was only about how to create new seafloor, and this is how it's done. Magma upswells in the cracks in mid-oceanic ridge, fills up that gap, and then solidifies. And then again, when they solidify, they are cooled down by the water, so they solidify immediately. They form basaltic rock. So how do we form then new crust that is not seafloor or not basaltic but granitic? This is how it happens. If the materials come out and then they find itself being cooled down not by water but by air, so they have time to expand, time to develop the crystals, so they become granitic rock. In fact, what we can uh, deduce is, for example, if this crack here, if this upwelling of the magma here is so active, so violent, that it kind of deposits magma here, deposits magma, and then let's say it's so active that it deposits a thick layer of magma, eventually this will poke out of the water. And guess what? When it pokes out of the water, that magma material will not be cooled down by the water anymore because it's above the water. So when that happens, as they develop this layer, guess what? That layer will now be granitic in nature because it's not cooled down by the water. Okay? So we can also have scenarios like what we discussed in the previous videos, like if you have an underwater volcano, that underwater volcano spews out magma materials, and again, as long as the magma materials is deposited under the water, those magma materials will solidify as basaltic rock, right? But the moment that it spews out enough material such that the new material now is on top or above the water, again, the cooling mechanism is different, therefore it now forms granitic rock. So that's how you form new crust. Okay? New seafloor when it's underwater, but if it forms above ground, above the water, you form also continental crust. But again, essentially, um, essentially it's like that. Another case for the continental crust being formed is also because of maybe um, maybe two continental. Well, we have actually discussed this before. Convergence of two plates. So if this is oceanic plate and another oceanic plates, again, one subducts under the other, forms underwater volcanoes here, and then eventually piles up the material, forming basaltic rock until it pokes out of the water, forming granitic rock. So that way you can form continental crust. But again, for the most part, because divergence, you see, when divergence happens in continents, eventually that continent will split apart into two and develop a sea. So therefore, all divergence always ends up in oceanic situations. So therefore, that's why we are only emphasizing new seafloor. But again, for the sake of the discussion, I also included how you form continental crust.